Hello everyone and welcome to the TOMILO interview room. I'm your host, Yuan Yuan. This is our fifth technical interview. We are honored to have invited an expert in the vehicle field, Senior Product Director Manager Bao. He will provide in-depth answers regarding vehicle environmental testing. Hello, Manager Bao.
Hello, host.
Why are we focusing on this topic today?
Well, we often see car advertisements showing vehicles speeding through icy landscapes, scorching deserts, or stormy weather. Behind these cool visuals lies a series of rigorous tests that vehicles must undergo before leaving the factory. This is what we call vehicle environmental reliability testing. Today, we aim to help everyone understand the role of environmental reliability testing in the vehicle development and validation process.
What role does vehicle environmental reliability testing play in the overall R&D process?
If developing a new car is likened to the National College entrance exam, then environmental reliability testing is the mock exam. Simply put, the core purpose of vehicle environmental reliability testing is to simulate the various extreme environments a vehicle might encounter throughout its entire life cycle, either in the laboratory or at dedicated proving grounds. This accelerated aging approach helps expose potential issues in a short period, ensuring that the vehicle delivered to the consumer is safe, reliable, durable, and of high quality.
From what you've said, this testing is indeed crucial. So, what are the biggest technical challenges in condensing the world's complex environments into test sites or laboratories?
Yes, this is precisely the challenge and appeal of our work. The main difficulties can be summarized into 3 points. First is the high-fidelity reproduction and coupling of environments. Natural environments are complex, variable, and involve intertwined factors. For example, a car driving in the desert simultaneously endures high temperatures, intense sunlight, dust, bumpy roads, and significant day-night temperature variations. Our challenge lies in accurately and synchronously replicating these coupled environments in the lab. We need to control not just temperature and humidity, but also simulate wind speed, solar radiation intensity, road vibrations, and even airborne dust concentration. Any deviation in these parameters could lead to failed test results. Second is ensuring test repeatability and continuity. To shorten the development cycle, we need to conduct accelerated tests. For instance, simulating years of corrosion and aging in just a few months. The difficulty here is the high demand on the stability of the test equipment. We must guarantee the repeatability of test cycles and ensure the entire process isn't interrupted by equipment failure. Third is real-time monitoring and intelligent diagnosis of massive data. Modern intelligent vehicles have thousands of sensors. During testing, we collect vast amounts of data, including temperature, pressure, voltage, current, and noise. The challenge is processing this data in real time and using big data and AI algorithms to quickly and accurately locate anomalies and predict potential failure points. This requires not only advanced data acquisition equipment, but also powerful data analysis and diagnostic capabilities.
So, it's not just a test for the vehicle, but an extreme challenge for technology, equipment, and engineering expertise.
Absolutely correct. We are using cutting-edge engineering to interpret and recreate the language of nature.
This next question is very practical. Such extreme test conditions undoubtedly involve high risks. So, what are the important safety issues and protective measures during testing?
Safety is always our top priority, the lifeline of all experiments. The safety system for vehicle environmental reliability testing is built around 3 aspects. Let's start with personnel safety. First, professional training must be conducted. All test drivers and operating engineers must undergo rigorous training and be certified. They need to be familiar not only with vehicle performance and equipment operation, but also master emergency response capabilities under various extreme conditions. Secondly, complete safety gear is essential. During extreme environment tests, personnel must be equipped with professional protective equipment, medical supplies, and communication devices. For example, testers need cold weather gear, masks, and the lab needs walkie-talkies, oxygen tanks, etc. Thirdly, there are clear operating procedures. Every test has standard operating procedures. For instance, during high-altitude tests, altitude confirmation, emergency pressure release procedures, and escape routes must be verified. Firefighting equipment must be in place for new energy vehicle high-temperature tests. Now, the second point, vehicle equipment safety. For high-risk tests, remote monitoring and intervention are critical. For high-risk tests, like high-temperature or high-speed tests, We use remote monitoring and control technologies. Engineers monitor vehicle status in real time from the control room. If parameters become abnormal, like a rapid rise in battery temperature, they can immediately remotely cut power or apply brakes. Integrated safety design. The test equipment itself has multiple safety protections. Dynamometers have overload protection. For example, environmental chambers have multiple over-temperature protection switches. And test vehicles are fitted with additional fire suppression systems. Third point, environmental public safety. The first is the use of control sites. The vast majority of our high-risk tests are conducted in dedicated, fully enclosed proving grounds, ensuring no impact on the public. The second is environmental protection measures. We have strict procedures for handling waste oil, exhaust gases, etc. generated during tests, ensuring compliance with environmental regulations.
It sounds like a tightly woven safety net comprised of systems, technology, and personnel awareness.
Yes, only with safety do the tests have meaning.
From your introduction, I deeply feel that vehicle environmental testing is a field crucial to the national automotive industry and has very high technical barriers. In vehicle testing, in which aspects can TOMILO contribute to China's vehicle environmental testing capabilities?
TOMILO has been deeply involved in high-end environmental test equipment for over a decade. Specifically, this is reflected in two main areas. First, we provide high-fidelity extreme environment simulation capabilities. Our full vehicle environmental chambers can accurately and stably reproduce various environmental parameters, like temperature, humidity, solar radiation, wind speed, and even pressure. They precisely simulate harsh environments from -40 degrees Celsius extreme cold to 60 degrees Celsius extreme heat, achieving a true time and space shift. This provides a powerful platform for automakers to conduct front-loaded testing during the R&D phase, significantly helping them shorten development cycles and reduce road testing costs and risks. Second, we create integrated dynamic test solutions combining environment and load. We believe a vehicle stationary in an extreme environment faces completely different stresses than one driving at high speed in that same environment. Therefore, we not only provide complex environmental scenarios, but also seamlessly integrate mechanical systems like chassis dynamometers and motor test benches into the environment. This means we can subject test vehicles to full scenario reliability tests, from static soaking to dynamic driving, in simulated extreme cold, high plateau, or high temperature conditions. This is crucial for validating the performance of the three electric systems: battery, motor, electric control, and powertrain in real-world conditions.
One last question which is of great concern to our OEM customers. Could you share the current solutions for fire safety in vehicle environmental testing particularly?
Okay, host. Fire safety is the lifeline of vehicle environmental testing, especially for new energy vehicles. Our solution focuses on building a comprehensive safety loop covering pre-warning, in-process control, and post-incident handling, ensuring fail-safe testing. Specifically, we follow a three-step approach. First, build a predictive intelligent early warning system. We no longer passively wait for visible fire. By deploying high-precision gas concentration sensors, smoke detectors, and temperature sensor arrays in the test chamber and on key vehicle parts, we can detect trace characteristic gases and temperature rise anomalies before thermal runaway occurs. This system alerts us before visible smoke or open flames appear, buying us the most valuable emergency response time. Second, activate precise and efficient active suppression secondary hazard control. Once the warning system confirms a risk, our automatic fire suppression system, using high-pressure water mist or Nova 1230 fluid, activates immediately. It quickly suffocates flames and achieves efficient cooling. Its advantages include fast extinguishing speed, good electrical insulation, and minimal secondary damage to precision equipment. The core purpose is not only to extinguish the initial fire, but also to create a safety isolation zone, preventing the fire from spreading and protecting personnel, the vehicle, and other key chamber equipment. Third, execute thorough and safe disposal of the compromised unit. After the incident is controlled, risks aren't fully eliminated. We have designed emergency transfer systems to move the vehicle experiencing thermal runaway to a designated safe isolation area or explosion-proof container for further handling. This step completely eliminates reignition risks, ensures the safety and cleanliness of the main test area, and allows testing to resume quickly. In summary, our fire safety solution isn't just about installing a few extinguishers. It's an intelligent, proactive safety management system, deeply integrated into the test process, designed to safeguard every extreme test for our customers.
Thank you, Manager Bao, for your detailed answers. We hope today's discussion has given everyone a deeper understanding of vehicle environmental reliability testing. If you have any questions, please leave a comment below our video channel. We will arrange for someone to answer them as soon as possible. See you in the next interview.
Goodbye.